Welcome back to the channel, Dr. Second Chance. I'm Dr. Second Chance. Today we're talking mathematics, math you need to know for the GED and the ASVAB test. Because if we do well in the ASVAB, you can get a better job in the military. And if you have dropped out of school and you need to get your GED to either go to college or perhaps get a better job, then you have to be able to do some of the math. So today we got a couple of topics. The first one is we're going to talk about the rules for exponents. Rules for exponents, and then a little later on we're going to talk about the volume of some geometric shapes. So let's begin with some rules of exponents. There's actually 6 of them. So here we go. When we are thinking about an exponent, we're looking at a base, and this number just represents, this letter just represents a number, and it's raised to a certain power. This here is called the exponent. And so remember that in mathematics and algebra, the letters just represent numbers. So this could be a 2, and the m could be a 3. That would be 2 to the 3rd power. So this is the base, this letter A, and the exponent in this example is m. And so with that, let's now begin to talk about some of the rules of exponents. First one's the product rule. And the product rule says that when you have 2 terms that have the same base, they're both A's, and they're raised to the exponents m and n. So you have a raised to the m and a raised to the n. When you multiply them together, which is what product means, the answer is a to the m plus n. And so let's do an example. Here we have x to the 2 times x to the 3. Well, using our rules, since x and x are the same base, and we have 2 and 3, this would be adding them together, or x to the 2 plus 3, which is x to the 5, x to the 2 plus 3. Here's another one, a little more tricky. 2x squared times 3x to the 5th. Well, the 2 times the 3 is 6, and the exponents, we have the same base, x. You have 2 and you have 5, and so multiplying x squared times x to the 5 is, using our rule, m plus n, that's x to the 7. So that's one of the first rules. Now I just want you to pay attention to something here, because this can be confused with some other things that are written that don't follow this rule. Here we're talking about the rule of a base to an exponent, same base to exponent, multiplied together. The rule is a to the m plus n. This is not the same as saying when we're adding them. A to the m plus a to the n does not equal a to the m plus n. And this is not the same rule as if we're raising it to a power. A to the m, all to the nth power, is a different rule, and we'll talk about that. So notice the difference. A to the m times a to the n. Not a to the m plus a to the m, not a to the m all raised to the a to the m. So that is the first rule. In a moment, we'll come back and we'll put up another rule and do some more examples. This next one will be the rule of, it'll be one of the rules. We'll see in a second. Welcome back, Dr. Second Chance here, and we're talking about rules of exponents. Here's the second one, rule of a power of a power. And this is when you have a situation of a to the m all to the nth power. In this case, you multiply. Well, Dr. Second Chance here, we're back. We're looking at more math, and this time we're looking at something called the quotient of powers. Now, this has nothing to do with Austrian powers, but here's the rule that when you have the same base, each raised to a different power, with the top one divided by the bottom one, the rule is this becomes am minus n. So in this one here, we have the same base, x and x. X to the 7th divided by x squared. That's going to be x 7 minus 2, which is equal to x to the 5th. Again, the quotient of powers. So a to the m divided by a to the n, same base, will equal a to the m minus n. So the quotient of powers. Now let's take a look at another one where you have a quotient, but it's all raised to a power. And that's the power of quotients. Well, I flipped the board, and here we are with the power of quotients. The power of quotients. When you have a divided by b, and these may not be the same bases, it doesn't matter, then this is all raised to, when it's all raised to the power m, then when you simplify this, this is a to the m and b to the m. A to the m, b to the m. And you could think of it as this also having like a 1 here. So a to the 1 times m is a to the m. B to the 1 times m is b to the m. So here's an example, x squared divided by y cubed, all to the 4th power. Well, when we spread this out, when we do the operation, this becomes x to the 8th, x to the 2 times 4, and y to the 3 times 4, which is 12. Y to the 12. So this is when you have a quotient, means one divided by another, and it doesn't matter if they're the same bases or not for this rule, and then you multiply the exponent of each. So 2 times 4 for the numerator, 3 times 4 for the denominator. That's the power of the quotient. We will look at what happens when we raise a base to the power 0, and we'll also look at some negative components when I put them up, which will be in just a second. All right, we're working our way through things. Now let's talk about 0 power. A base to the 0 power, by definition, is 1. So x to the 0 is 1. So this is a real easy, fast way to get some points on the test. Now, something that's a little more tricky, but again is a way of getting some great, quick, fast points on a test. If you have everything that's in brackets to the 0, it is also 1. And so the fact that it's x squared, y cubed, you could have a whole bunch of other terms in here, doesn't matter. All of the brackets to the 0, by definition, is 1. So that's the 0 power rule for exponents. A base to the 0 is 1. And so if you see that on the test, then that's a quick score of a point. Now, where sometimes they will also confuse you is they might throw in, what is a to the 1st power? And the answer to that is a. When we write, whether it's a, x, y by itself, it's also understood to have a 1 there. We just don't write it by convention. So a to the first is a, and so that's also by definition. So that's the 0 power. Now let's look at a negative quotient. And what that means is, a negative exponent. And that's where we have a negative number as part of the exponent. So I will put that up and we'll get right to it. Well, here we go. Negative exponent. A to the minus m, by definition, is 1 over m. And so x to the minus 2 is 1 over x squared. And if you have, so it inverts it and it gives you a positive number. Because what you want to do most of the time when you're solving these is end up with positive exponent numbers. And so we flip things around. A to the minus m is 1 over m. Similarly, 1 over a to the minus m is a to the m. And so on this one here, look at this bottom example. 5 divided by 20 is 1/4. And so x to the minus 2, we can see here, becomes 1 over x squared. So we put x squared on the bottom. Y is fine where it is. And then there's a z to the minus 5. That actually flips it up. Just like 1 over a to the minus m, here we have some stuff over z to the minus 5, which brings the z up top, z to the 5th. And so this way, when you answer, if you have negative exponents, you want to write them all as positive exponents in your answer. Yeah, so because the question would be like, why not just leave it like that? Well, what they'll usually want you to do is to, again, write it in a way where all the exponents are positive numbers. Well, that concludes our rules of exponents. I highly encourage you to practice those. You can look up lots of practice questions online. In general, they're, with practice, not difficult, and a very easy way to secure and score a bunch of points relatively quickly. So yes, let's do it. We're now going to turn our attention towards some volume calculations, volume. And whenever we're talking about volume, we're talking about if you had like a cube or a rectangular prism or a three-dimensional shape, and if you're filling it with water, how much water would be in there? How much could it carry? So sometimes it's also called capacity. So we're going to talk about a few volumes when we come right back. All right, I got some volume questions up. Let's start with the volume of a cube. Volume of a cube. And again, volume is measured in cubic units, like cubic inches or cubic feet or cubic yards or cubic centimeters, as opposed to a square, which is measured in square units. So anyways, here's a cube. By definition, a cube has all the sides the same. So you think of a cube of a die or an ice cube that's perfectly shaped in all directions. Most of the ice cubes out of the trays look more like rectangular prisms, but a perfect cube, same length, height, width. So the volume is the side cubed. And so if this was 3 centimeters, then it's going to be 3 cubed. So the volume will be 3 cubed, which is equal to 3 times 3 times 3, which is 27, and if it's centimeters, cubic centimeters. That would be the volume of the cube, volume of the cube. Now, if we wanted the surface area, which is the area of all the surfaces put together, it's 6 times the side squared. So the surface area of a cube would be 6 times 3 squared, 6 times 9, 54 square centimeters. Notice here it's squared centimeters, and here it's cubic centimeters for the volume. So the surface area is that. So when we come back, we'll take a look at a rectangular prism. A rectangular prism. So here we have a rectangular prism. So a rectangular prism would be something like, here's the cleaning brush for the board behind me, and you notice that it's a rectangle shape, but then it also has thickness or height. So a rectangular prism will also be in cubic units because it occupies a volume. And the formula is the length times the width times the height. Suppose this has a length of 11 and a width of 4 and a height of 3. Then we multiply those together, 4 times 11 times 3. And that answer, 11 times 4 times 3, that's 132 centimeters cubed, or cubic centimeters. So that is the volume of a rectangular prism. And again, these formulas will likely be given to you on your tests on some sort of sheet, but do some practice problems just so that you get into the habit of being able to do them quickly. You need to pick the right formula, put in the numbers, and then make sure the units that you assign to your number value are correct. If it's a volume, it has to be cubic. If it was an area, you remember the area of a rectangle is the length times the width. And so if this was 11 and this was 4, the area in this case, which is what we're looking at, all of this, would be equal to 11 times 4, which is 44 centimeters squared. It's that would be the area of that rectangle. But a rectangular prism has cubic units. All right, when we come back, we will look at the volume. I need to put it up on the board, of a cylinder, a volume of a cylinder. Well, okay, I've got up the volume of a cylinder, and one of the things that's interesting to see on this is that if you look carefully, the volume of a cylinder, which is volume, which is cubic units, is basically the area of a circle times the height of the cylinder. And so we can calculate that as the volume equal to pi r squared times the height. And so if we know what pi is, 3.14 is an approximation. R squared, if it's here 2 centimeters, that would be 4, and the height is 6. And then if we multiply that out, that's 75.36 cubic centimeters. And so the volume of a cylinder is the area of a circle times the height. And remember that the area of a circle The area of a circle is pi r squared. And so you don't want to confuse it. This will give you square units, and volume is cubic units. So again, I thoroughly encourage you to practice these questions at home, and those examples, look them up, practice them. There's some others like the area of a cone or a square pyramid you can look at as well. I probably wouldn't spend as much time on those, but definitely you can look at those other examples, the cube, the rectangular prism, the cylinder. There will definitely be volume questions on that. Oh, I didn't put up the volume of a sphere. Well, we'll do that next time. Anyways, again, Dr. Second Chance encouraging you, practice, do well in these exams. I know you can do it, and we will see you the next time.